again, everyone. Welcome back to DIY The Art of Wood. I'm Jeremy, and today we're going to be talking about cars and a common electrical problem that's often misdiagnosed with a car that has a repeated dead battery. Now this car right here is a perfect example. Over and over, go to start it, dead battery, have to jump it to get it back on the road again. Now most people will jump to a couple conclusions there, one being either the battery's bad, need to replace it, maybe the charging system's bad, need a new alternator, or maybe the starter's bad, need to replace that. Sometimes that's true, but there's a fourth possibility there that's often either misunderstood or misdiagnosed. That's the actual root cause of the problem, and that's what's known as an electrical drain. Now when your car is off, there are things in the car, especially modern cars with electronics, that are pulling a little bit of amperage off the battery. And there is an acceptable threshold that can be in that is still okay, that won't drain so much off the battery that the next time that you go to start it, you'll have a dead battery. But sometimes there's something on in the vehicle that's still pulling amperage off that battery while it's off, that's above that threshold, that will pull so much energy off that battery that it will drain it dry like a vampire, and the next time you go to start your car, you got a dead battery. And when I worked for my dad, I don't know how many times we'd have customers come in through the door with this very problem. They had tried to fix it themselves. Been to AutoZone or O'Reilly over and over and over, buying battery after battery, alternator after alternator, cursing at AutoZone about selling junk products. Well, problem is they're misdiagnosing the problem. And it doesn't matter how many batteries you buy or how many new alternators you put in there. If you have something that's draining that battery while it's off, past that threshold, eventually it will drain that battery dry and you won't be able to start your car, and you'll be back to where you started. And in a few minutes we're going to dive right in, and I'm going to show you how to check if your car has a drain. But first, let's take a closer look at some of the common terms and concepts behind automotive electricity. When it comes to electricity, there really is a lot to be learned, but for today all we need to concentrate on are two main points, and that's voltage and amperage. Now some people get those things confused, or they don't really understand the differences, and there's a couple of different ways we can look at those to kind of create a word picture so you can understand what those two things mean. Voltage really relates to power, and amperage is more about the flow of electricity through a wire. And one of the ways that I like to look at it is from a physics standpoint, where voltage is kind of like potential energy and amperage is more like kinetic energy, or maybe an even better word picture would be like water in a pipe, where the voltage is like the water pressure and the amperage is like the flow rate, or the gallons per minute. Now when we're talking about amperage in a vehicle and testing for an electrical drain, we're going to be talking mostly in milliamps, or thousandths of an amp. Now to give you a little perspective on what that really means, a typical glove box light in your car is going to draw about 250 milliamps, or a quarter of an amp. Now earlier I talked about how most modern vehicles will have some sort of amperage draw, even when they're off. Typically you'll find about 10 milliamps or less. That upper threshold is about 50 milliamps. Now if you go above that 50 milliamps, you're probably going to have a problem with dead batteries pretty regularly. And if you find that through the methods I'm outlining on this video, you need to dig a little bit deeper into why your car is causing that problem. One of the most typical causes for an excessive drain like that is an improperly installed stereo. There's one more thing I want to mention about performing this test. Some vehicles will have a hood open sensor that will draw additional amperage when you have the hood open. So if your vehicle has one of those hood open sensors, what you'll need to do is make your connections at the battery with your multimeter, and then gently shut the hood so it turns that sensor off so it doesn't throw your readings off. Additionally, you'll want to make sure that your glove box is closed, that your dome lights are off, that your doors are shut when you're performing this test. Otherwise, all those lights are going to be drawing amperage, and that will also throw your readings off. Okay, before we begin, a couple little safety tips. Good idea to wear some gloves if you have them. You don't want to get that battery acid or any of that nasty stuff on your hands there. And definitely wear safety glasses. You don't want to get any of that in your eyes. Okay, so the first thing you'll want to do is disconnect one of the battery cables. Now the safest way to do this generally is to work off of the negative side of the battery. Pretty easy to tell which is negative, which is positive. Positive generally marked with red. See, this has this red cap over the terminal here. Also the cable coming off of it is red. And usually somewhere on the battery near the terminal here will be a plus sign indicating that this is the positive side. Same thing over here, except that this is black generally. And there should be some spot here on the battery as well near the terminal that will have a little minus sign for the negative or the ground side. So we'll go ahead and disconnect this cable and get started. Oh. Looks like maybe somebody over tightened this one. It's okay. Let's grab our locking pliers here. Grab the back side. Should be able to get that off now. That should be loose enough now. Come right off, hopefully. There we go. Now you'll want to kind of set this back a ways as much as you can out of the way so that the cable doesn't reconnect here at the terminal. You want to keep those separated. If you have to, kind of maybe strap it back with a zip tie or something like that. I should be able to kind of pull this back enough to be out of my way. So that'll work okay there. Now, the next thing you'll need to do is grab your multimeter, one of these guys, and we're going to set it to the current or amperage scale indicated here by a 10A for 10 amp scale. And as far as the leads go ahead and connect the red lead to the amperage port. This one's marked with a 10A. This one's marked with 10A there, right above it. And the black lead will go to the common port. Now, just a little word of caution here. Batteries can discharge a little bit of hydrogen gas, so it's generally safer to first make your connection actually at the battery terminal here, and then make the connection at the cable to prevent a spark right at the battery and prevent a little explosion. So what we'll want to do to conduct this test is first make the connection at the battery here, and then make the connection at the battery cable, and that will allow current to flow again. And we'll just watch what the amperage does. Now we get an initial spike there, and as you can see, it's slowly but surely dropping off. It started out at looked like about 700 milliamps. Now it's down to 220. And I'll hold it here for a little bit longer and see if it drops down any further. Drop down to 140. Now it's at about 60 milliamps. So that's kind of near that upper threshold that I mentioned. And that's fluctuating back and forth between 60 and 50. So that's up near that upper threshold that I mentioned. So I'm going to conduct that test again, and then we're going to watch it kind of drop down to that what appears to be the bottom level, and I'll explain what's happening there while it's going down. I will make my connection at the battery first, and then at the battery cable. So we get that initial spike, and then it immediately starts to drop down. And what's happening there is on modern cars, there's a lot of electronics that will draw a little bit of amperage for a short while, and that's usually for memory purposes for the most part. And then they slowly but surely start to time out or shut off. And that's what you're seeing happening here, is different components in the vehicle are drawing amperage for a short period of time, and then they're starting to drop off. See, it's holding at this 220, now it's dropping back down to 148 milliamp. And then it seems to kind of bottom out here at about fluctuating between 50 and 60 milliamp. Now it's possible there's something on in this vehicle that has an extended timeout period like I mentioned earlier. And what I'm going to need to do is set this up so it will stay connected for a while, and then maybe come back and check it every few minutes. So I'll do that right now. Now if you have a multimeter with alligator clips on the end of it where you can clamp them onto the battery terminal here and then the cable and just leave it, that's great. But if you have these kinds, it's a little bit trickier, but I've got a solution for that as well. Just grab yourself 2 pair of locking pliers and set one up on there like that. You don't really want to clamp this so hard that it deforms the terminal, just enough to hold it on there. There we go. And then do the same thing on the battery cable. Another pair of locking pliers with the other lead. There we go. What I'll do is I'll leave this on for a little bit and then come back and check it every few minutes or so and see if it finally drops off to a level that's a little bit more ideal. Okay, it's been about 20 minutes and we're still holding strong here at that same level, about 50 to 60 milliamps. Thought this would be a good time to mention one other thing here. If your vehicle has a light under the hood that comes on when you lift the hood, you need to disable that before you conduct this test, because you'll pick up that amperage draw for that hood light once you make that connection. Now it's possible here on this vehicle that it has a hood open sensor or indicator. I don't see that light on in the dash. I don't hear any buzzing, so I don't think this one has one. So I will continue to watch this for a little while, and if it doesn't drop down after that 45-minute mark, I'm going to conduct this test again with the hood closed. Just have to kind of set this up so my cables, or so the meter can be outside out here. The cables kind of run through the hood, gently shut it so it doesn't sever the cables, and then watch it then and do that test one last time. And if it still fails, if I'm still seeing this higher than ideal number, then that tells me there's something else going on with this vehicle, that there's something on that's drawing a little bit more amperage than it probably should. Now, this isn't just wildly out of whack, but this is again right kind of at that threshold where after a long enough period of time, if the car sits, you'll have a dead battery. Or if you take a lot of very short trips to where the alternator doesn't have a chance to recharge the battery and you start it over and over and over again, you know what? Eventually that will catch up to you. The battery will just keep getting lower and lower and lower and not get a chance to recharge. And eventually you go to start your car, dead battery. Okay, so it's been about an hour and we're still at that same level. One last thing I'm going to try here is I am going to set this up so I can put the meter outside and shut the hood just in case there is a sensor here somewhere that I'm not seeing for the hood. And beyond that, I'm going to say that this car does have a little bit high of an amperage draw. It's not excessively high, but it is a bit high. Okay, so this will be just a little bit trickier. I'm going to have to kind of set these leads and these locking pliers up so that I can still shut the hood. So I'll have to do some rearranging here somehow. Try to kind of get these to lay flat, I guess. Best I can. Okay, so we've got that one on there. And we'll have to figure out something for this guy down here. Okay, I think that'll work. We've got our reading still. And what I'll do is I'll bring this out, go kind of under like that, and then I will shut the hood. Kind of tricky. There we go. And then we'll watch if that drops down at all now that the hood's shut. There we go. Okay, so we're still hanging out around that 50 to 60 milliamp range. That's not excessively high, but it is kind of at that threshold that is less than ideal. Couple things come to mind. First off, usually something like this is most likely going to be caused by an aftermarket electronic device that's been added, like a car stereo. Now, I do know this vehicle had a remote start added to it not too terribly long ago, so that is a likely culprit that was not installed properly, and that's drawing amperage when it shouldn't be. So that's one thing that I would look for in this particular vehicle to see if that is what is causing this. Now, in this particular video, I'm not going to dive into trying to find where this drain is coming from. I think I'll save that for another video. That can get rather extensive and involved. It's a little bit beyond the scope of this video, but we did find that there might be something going on here that you need to take a closer look at. But at least you'll know what to look for and where to start. And so that's pretty much it. It's a pretty simple little diagnostic test you can do yourself as long as you have access to a multimeter. And it could save you a lot of trouble if you're having that issue with your car where you keep having dead battery over and over. Save you a lot of time and money buying new batteries and wasting a bunch of time. So I hope that helps you out, and I'll see you on the next video. If you do find that your vehicle has a drain, tracking those down can be really tricky. But if you do find that, at least you'll know what you're looking for. Or if you take it into an auto electrician, you can tell them that you found a drain and they won't sell you something you don't need. DIY the art of wood, DIY the art of wood, DIY the art of wood. Kind of wanted to get the microphone in the shot too. Can you kind of see it? Don't move the camera, I'll move this. Testing, and we are now testing for proper modulation. This is nice, because I can stare at you, which you're kind of almost in line with the camera. Like if you moved over just a little this way, just a little tiny bit, I stare into your pupil. So when talking about electricity in a vehicle, there's two main components you want to understand. The first is voltage, and the second is amperage. Some people don't. Start over. Hey. Action.
Sorry.
The art of wood, DIY the art of wood. So when speaking about electricity, there's a lot. You really need to concentrate on our two main points, and that's voltage and electricity. Electricity. Start me over. I'll just delete some of these. The art of wood, DIY the art of wood. Voltage is like potential energy, and I still don't like this one. About electricity, there really is a lot to it, and there's a lot to learn. But I hear your footsteps. There's a couple different ways we can look at those to kind of, simplify. I hear Mabel snoring.
Mabel's snoring. Mabel, come here. Come here, Mabel. Come here.
You gonna put her in the bedroom?
Yeah, come on, Mabel.
The art of wood, DIY the art of wood. Gallons per minute. I can cut that. A typical glove box light is going to draw about 250 milliamps, or roughly a quarter of an amp. No, that's not right, because that's exactly a quarter of an amp. So, the threshold, and that upper threshold is about 50 milliamps. Typically, you're going to find. I thought it was off, but sometimes when I set it down, it pushes this button and it. I'm just gonna start talking over again. Take. No. I was just talking to myself. I had it so perfect on that earlier one. What did I say? Now the vehicle in this video did not have an exhaust. Now this is hard. It's really hard. You should try it one time. Get a little drink of water. DIY.